All right, students, this is the beginning of Chapter 7 here, our first lesson in Chapter 7, and we are going to learn about zero and negative exponents. You're going to learn how to simplify exponents that are negative. I'm sure you're familiar with exponents a little bit. So here's some things for this chapter that you'll have to know how to do. So get ready for this chapter. Converting fractions to decimals, I'm going to do this one right here. And the whole number 6 represents 6 point something, and then to divide into the decimal, you just have to do 2 divided by 5. You can use that calculator if you want, but that's 0.4. So if I convert that to a decimal, I get 6.4. Using the order of operations, once you have exponents, you have to know that exponents need to be simplified before you multiply and divide or add and subtract. So I'll just pick one of these that I think you may have an issue with. Let's look at this one here. We have 4 divided by 0.5 squared. So the first thing we're going to do is multiply 0.5 times itself. And if you remember, 0.5 is really just a half. So I got a half squared, or a half times a half, which is a fourth. So this equals 4 divided by a fourth, or 0.25. And that equals 0.25 goes into 1 4 times, so it goes in 4 16 times. All right, evaluating expressions. Again, we got to make sure we remember the order of operations. Let's do number 17 here. It says, so I'm going to substitute 5 for B, and then I'm going to substitute -2 for A. So 3 times -2 in there to the second power. And do parentheses first, so that's -6 to the second power. Now I'm going to do exponents. -6 times -6 is positive 36. And 5 minus 36 is -31. All right. Finding percent change. Here's something that a lot of students seem to have problems with. The percent change, a lot of people, when they're doing percents, they just think they can divide the two numbers, 15 divided by 20, and change it to a percent. But that doesn't work with percent change. You can get the answer from that as long as you know how to read your answer and how percents work. But the best way to do it is to figure out how much change there is by subtracting. So 20 minus 15 is 5. And then use that and your original amount to get your percent change, because you want to know what percent it changed from the number 15. And 5 out of 15 is 1/3, or 33 1/3%. So, and that's an increase. So a 33 1/3% increase on that one. All right, understanding domain and range. So find the range of each function with the domain -2, 0, 3.5. Really, the domain is x, and the range is y. That's good to think of it that way. And so we want to, I'll do the first one here, f of x equals -2x squared. So if we do -2 times x squared, that will be our range. And then our domain are our input values, -2, 0, and 3.5. I'm not going to do them all, but basically I just need to find what -2 times -2 to the second power is. And again, I'm going to do my exponent first. So -2 squared, that's -2 times -2 is +4, times -2 is -8. I put 0 in there. Well, anything multiplied by 0 is equal to 0, so that one's not too bad. And to do 3.5, you're going to do -2 times 3.5 squared. And I'll let you guys do that with the calculator. All right. So the big idea here is how to deal with zero and negative exponents. Here's some review things. In general, the exponent is the little number there, so we'll circle the exponent in each of these. And what that tells you is how many times that base is a factor of that number. So here we see that we have 35 is a factor 3 times. So the 3 represents how many times we're multiplying by that. And here we have 19 9 times. In the expression 4 to the third, the base is equal to 4 and the exponent is 3. I'll write a number to represent each situation. And draw a line from each negative number to its opposite. That one's pretty easy. So opposites are two numbers that add up to 0. And I'm going to go through this example with you, and I think you have a spot for this in your notebook, but just to get an understanding of what negative exponents mean here, I think it'll help to look at this table. So 2 to the fourth, that is 16. 2 to the third is 8. 2 to the second is 4. 2 to the first is 2. And if you think about as I'm going down this table, I'm really dividing by 2. So every time I subtract one power from the exponent, like if I go from 2 to the 20th to 2 to the 19th, I'm really just dividing by 2 to get from there to there. So if I subtract one exponent, that means dividing by the base. That one time. So every time you subtract one from that exponent, that's a time you're dividing by that base. So 2 to the 0, if I keep dividing by 2, 2 divided by 2 is 1. So, and one thing you'd want to do is maybe check that out, because a lot of people would think 2 to the 0 is 0, but that wouldn't fit this pattern at all. If we had 0 and then we divided by 2 again, we'd be stuck at 0. So that wouldn't work out. 2 to the negative first is our last number divided by 2, which is a half. And I'm going to write that as a fraction, 1/2. And if I divide a half by 2, I get 1/4. All right? And for most of these problems in this lesson, we're going to want to use a common fraction to represent our answers, not decimal. It's really hard to understand negative exponents when you're using decimal. All right, so here's our powers of 10. 10 to the fourth just means 10,000. 10 to the third is 10,000 divided by 10, which is 1,000. 10 to the second is 1,000 divided by 10, which is 100. Divided by 10 is 10. Divided by 10 is 1. Divided by 10 is 1/10. Divided by 10 is 1/100th. Now, what I really want you to notice here is that 10 to the negative 10 is the same denominator as the number 10 to the second. So 10 to the negative second is 1 over 10 to the positive second. And same is true for 2. 2 to the negative second is exactly equal to 1 over 2 to the positive second. So if you ignore the negative sign, that's going to be your denominator. Or and I'll just give you one more quick example. Let's say we have 6 to the negative third. Well, 6 to the third is 216, so 6 to the negative third is 1 over 216. And the other way you can think about it is this. If you start at 6 to the 0, anything to the 0 power is 1. And then subtracting and 1 in the exponent, in other words, going to 6 to the negative first, is really dividing by 6. So 6 to the negative first would be 1 divided by 6, or 1/6. 6 to the negative second would be 1 divided by 6 twice, which would be 1 over 36, and so on. So let's do a few problems like with this. And here's those rules I was talking about all set up in the table for you. Any number to the 0 power is 1, and we saw why that has to happen. If it was 0, then exponents wouldn't work out very well, because once you start multiplying from 0, you're stuck at 0. So 7 to the negative third, for every non-zero number a and integer n, a to the negative n equals 1 over a to the positive n. So we'll finish this problem here. 4 to the negative second is 1 over 4 to the second, and 4 to the second is 4 times 4, which is 16. Negative 3 to the negative fifth is 1 over negative 3 to the fifth, which is 1 over, think about, let's see, 3 to the fourth is 81, 243, negative 243. Something interesting happens when you have negatives. If you do negative 3 to the first, you get negative 3. Of course, anything in the first power is itself. If you do negative 3 to the second, that's negative 3 times negative 3, which is positive 9. Negative 3 to the third is negative 27, because now we're multiplying by a negative factor again. And so when you have a negative base, you can see that the answers alternate positive and negative depending on whether it's an odd or an even power. So negative 3 to the fifth is negative 243. All right, so let's write true or false here. 9 to the negative second equals 1 over 8 in the first. The rule says it equals 1 over 9 to the positive second, which indeed is 1 over 81. Any number to the 0 power is 1, not negative 1, so that's false. Any 9 to the negative first is 1 over 9 to the first, and 9 to the first is just 9, not negative 1 9, so that's false. And 9 to the negative third is 1 over 9 to the third, which is 1 over 27. That's true. All right, so what is the simplified form of each expression? Well, to deal with the negative exponent, all you have to do is turn it into a fraction, and the denominator is that same base with the positive exponent. So, and simplifying that, let's get rid of the powers to be completely simplified, and that would be 1 over 36. Okay? The second one, negative 9.3 to the 0 power, is equal to 1, because any number to the 0 power is 1, except for 0. 0 to the 0 power is undivided. But now, some of you might be thinking this, what if it was this? Well, that is negative 1, because the negative in front of that just turns that into a negative number. The difference being that this has parentheses and this doesn't. All right. So go ahead and try a couple problems here and check back on your answers. All right, we can use the same idea with variables. So we're going to just write this, think of this as 3 times 1 over 8 to the second. Remember, a negative exponent can be dealt with by making it into a fraction with the numerator 1 and the denominator of that number with a positive exponent. And then times b to the third. And if we want to multiply this out, we would get 3 times 1 times b to the third is 3b to the third. And then the denominator is 1 times a to the second times 1. We can also use that idea backwards. If we have 1 over x to the negative 6, that should be the same as x. And we just need the opposite of that if we don't have the fraction. So x to the positive 6th power is the same as 1 divided by x to the negative 6th power. And just to show that that's true, well, what if we put a base in there? And this is a good idea just to try some examples. But 1 over 3 to the negative second, that's equal to 1 over, and remember, a negative exponent means a denominator of 1 and a numerator of that same base with a positive exponent. And that's 1 divided by 1/9, which equals 1/9 goes into 1 9 times, so that's equal to 9. And if we look back to the beginning, that 9 is actually 3 to the positive second, so 1 over 3 to the negative second equals 3 to the positive second. So that makes sense. Go ahead and try. Next one, check back with your answers. All right, so here's your answers here, and I'm running out of space, so we're going to do a part 2 of this video.